All right, so yesterday we looked at solving equations. Today we're going to look at solving inequalities. Okay. Big difference is instead of having an equal sign in the problem, it's going to be replaced with one of these four symbols. Here's two examples of inequalities. The one on the left is a true statement. The one on the right, it's more like a conditional. It depends on what you pick for x, if it would be true. But if you want to check if something is a solution, just like an equation, you just plug it in and see if you get a true statement. So let's say we wanted to check if the number 5 is a solution to that inequality. We just fill 5 in right there. When you fill in 5, what's 3 times 5?
15.
Is 15 greater than 12? Then yeah, 5 would be a solution. Let's try 4. 3 times 4 gives me 12. Is 12 greater than 12? No, so 4 is not a solution. So if you want to check if a number is a solution, you just plug it in and see if you get a true statement. Okay. Sometimes we have two inequalities like that, but they're connected with the word and. Okay, that is a conjunction. When we write two inequalities with the word and, that's one way to do it. X is greater than -1, and x is less than 3. Or you can combine them. So a lot of times when you have a conjunction, they shorten it by doing this. They put the variable in the middle, smaller number on the left, bigger number on the right, and both inequalities point to the left. When I say point, I mean like the point of the arrow. Like if you made it into an arrow, like that, they're pointing left. So if I had something like, just make up another example. X is greater than 5 and x is less than 20. Let's combine that into a shorter format. When we combine it, where is the x going to go? Yep.
In the middle.
Yep, x in the middle. What number would go on the left? Yep. 5. Number on the right? Yep, 20. And both my inequality symbols are going to point towards what number? Yeah, they're both going to point to the left, towards the 5. There you go. Now, if you had one that's already combined, let's just pick some different numbers. Let's look at this one. And now I want to separate it. The way you separate it is here's your first one, and here's your second one. So the first one is x is greater than 4. And what's the second one? X is less than 10. There you go. So you can take something that's combined and split it, or take something that's split and combine it. Either way. Okay, all three of these that I just did, they're all talking about what we call an interval, or like a range of numbers. This is the range of numbers between -1 and 3. This is the range of numbers between 4 and 10. And this was the range of numbers between 5 and 20. So we're going to talk about some different words that we can use to describe these intervals. And the words that we're going to use are bounded versus unbounded, and open versus closed. Okay, bounded and unbounded go together. Open and closed go together. So they describe different things. This particular interval that we just did is what we call an open interval. So I'm going to explain what makes it open versus closed. in what makes something bounded versus unbounded. So there are 4 different types of bounded intervals. Okay, what makes something bounded? Well, bounded means that the actual endpoints in your intervals are numbers. Right? These are my 2 endpoints. -1, +3. Those are numbers. What do you think you could have that would make it unbounded? Instead of a number, you could have what symbol we used before? Yeah? Infinity. Yeah, when you see infinity in an interval, that's unbounded. Okay, we're not talking about that yet. Okay? So we're talking about starting at a number and stopping at a number. One example of a bounded interval is that it can be closed. What closed means is that if you're going between the 2 numbers a and b, you can include the a and you can include the b and everything between. So closed means you can include a and b. Right? Versus the opposite of a closed interval. What do you think that's called? Yeah? Oh, yeah, open. And the difference here is you're still going from A to B, but you cannot include the A and you cannot include the B. So it's everything between A and B, not including the A and the B. That's the difference between closed and open. Now I said there are 4 types. There's 2. What other type do you think you could have besides closed and open? Yeah?
Like partials of the 2?
Yeah, you could have like a half open. So you could have half open on the right, or the bottom one is half open on the left. So as a picture, this means you can pick a number between A and B. You can include A in the numbers you pick, but you can't include B. So it's still bounded because there's a lower limit and an upper limit. It's between 2 numbers. And same thing with this one. This is still bounded because there's a lower limit and an upper limit. But in this one, you cannot include the lower limit, but you can include the upper limit. And of course, anything in between. So the way that I wrote them all on the left, all of these, those are called interval or set notation. So if you see a question on the test that asks you to write something as an interval or in set notation, I'm looking for this notation. There's no less thans or greater thans in set notation. There's only brackets, parentheses, and commas. And 2 values, which could be like 2 and 7 or something. If I ask you to represent an interval graphically, okay, graphically means you have to make a number line, and you're going to draw an open and a closed circle on it. Okay, so this uses a little bit different representation, even though they mean the same thing. This is a set or an interval. This on the right is a graph. And the ones we did up above, these are called inequalities. Right? Whether you use the word and or you combine it together, these are both inequalities. So now we've got kind of 3 different ways to represent the same thing. And we'll practice all 3. Okay, so those are bounded. And the opposite of a bounded interval would be? Unbounded, yeah. So we know an interval is unbounded when it goes on forever. So an example of an unbounded interval would be any of those. Those are different kinds. Okay, I'll draw two of them. This one means you can pick any number from 5, including 5, and higher. When you do the shading, it has an arrow. The arrow means it keeps going. It never stops. What's the highest number you can pick here? There is no highest number. What's the difference with the one below it? Yeah. You can't include the 5, so what kind of circle would you put on that? Yes. Open circle, shaded to the right. Notice, what kind of symbol do you always see next to an infinity when you write it in set notation? Yeah? It's always a parenthesis. Always. You cannot put a bracket on infinity. Putting a bracket on something means you can actually include and reach that number. You can't reach infinity. So never put a bracket on an infinity symbol. That doesn't make sense. And the two on the left would be very similar, but they would be arrows pointing to the left, not the right. And I drew out two of them for you. You can look at page 100 if you want to see pictures of the others. Okay, so now let's try translating this into an inequality. What's the name of this notation? Yeah?
Interval.
Yeah, interval notation or set notation. Yep. Now we want to write it as an inequality. When you write something as an inequality, first thing you need to choose is a variable. There's no variables in set notation, but as an inequality there is. What do we normally pick for a variable when we write inequalities? X. You don't have to, but we will. So let's pick x. Where would the -3 go? Yep, to the left. And where would the 5 go? To the right. And what kind of symbol are we going to put between the -3 and the 5? I'm sorry, between the -3 and the x? Less than. And how about between the x and the 5?
Or less than. Wow.
So what symbol are we going to put here?
Less than.
Nope, not a less than.
Oh, less than or equal to.
Less than or equal to. Okay, so remember, if it's a parenthesis, it doesn't have the equal to. If it's a bracket, then you need to put the equal to. Any question on that one? Is this a bounded or an unbounded interval? Bounded, because I'm telling you the lowest number you can pick is -3, the highest number is 5. Doesn't go on forever. Yes?
How do we know which if it's less than or greater than?
When you're writing it as an inequality,
Yeah.
if you put your smaller number on the left and your bigger number on the right, they always have to point to the left.
So it's always going to point to the left and the right.
As long as you put the smaller number on the left and the bigger number on the right. If you don't do that, then no, it could be this. If you switch where you put the 5 and the -3, now you have to do this. That's still correct. That's exactly the same thing. But you've reversed everything. Okay? All right, let's look at this one. So there's another interval in set notation. What's what kind of interval is that? Bounded or unbounded? Unbounded. Okay, it goes to infinity. There's only a lower limit. There is no upper limit. What kind of numbers is this telling you that you can pick?
-4
And how would you write that as an inequality?
-4 is less than
or equal to x is less than, oh no. Infinity?
Less than infinity? Like that?
It's not feeling good.
Okay. We could shorten that a little bit. What is this telling me?
Oh.
That's basically telling me what? So, not quite. What does this mean? The part that I circled. Yeah?
X could be any number.
Less than because infinity has to go.
So it says x is less than infinity. Okay. What number isn't less than infinity? Nothing. So saying that something's smaller than infinity, yep, I know that. Everything's smaller than infinity. So you don't have to say x is smaller than infinity. You could just say this first part. Any number greater than or equal to -4. This is the same thing you had. I like to put the letter on the left instead of on the right.
If we were to write that on a text, like the whole thing, but is less than infinity, would we get it wrong?
No,
Okay.
no. But if you click in the box and the infinity symbol doesn't come up, and you're like, oh, you come up to me during the test and you're like, oh, I gotta type infinity right there, I'm probably just gonna smile. But I won't be able to explain why you don't need it. But you don't need it because everything is less than infinity. Okay. So yeah, you just have to say x is greater than or equal to -4. And how about this last one? Bounded or unbounded?
Bounded.
Bounded, okay. Bounded, those are the ones that are a little more complicated. You gotta put the x in the middle, and then you gotta put numbers on each side. Unbounded is actually shorter to write. You don't need an x in the middle. This one we do. What number would go on the left? And on the right? And what symbol are we gonna use in both spots? Yep. Less than or what?
Oh, sorry. Less than or equal to.
Less than or equal to. And that's how you write this one. So that's your inequality. That's your interval or set notation. Okay. Questions on going between those two? Now let's try going from this to a graph. What kind of notation is that? Yep.
Inequality.
That's inequality. So with inequality, you got a variable, you've got one of 4 symbols, and then you have a number. There are no brackets and parentheses when you write things as an inequality. We don't use those symbols. That's set notation or interval notation. Okay. And now with graphing, we use other symbols, open and closed circles. Okay, so we've got our number line. What kind of circle do we need for this one? Closed, and on what number?
2.
So closed on 2. And now how do we do the shading? Luke?
To the right.
Yeah, we're going to shade all numbers that are 2 or higher. So that would be this way. So inequality, graph. Any question on that one? Let's try this one. First, is this bounded or unbounded? It's unbounded. That means when you sketch it, it's going to have an arrow. It keeps going and it never stops. All right. What kind of circle do we need for this one?
Open.
Yep, open. And what number are we going to put it on?
5.
Put it on 5. And this time we're going to shade which way? Yes, everything that's less than 5, that's the numbers going this way. And how about this one? Bounded or unbounded?
Bounded.
Bounded. That means we're not going to have an arrow. We're going to have two circles. We're going to shade between. So we need a number line. What kind of circle do we need on the -1?
Closed.
Closed. And on the 3? Open. And where do we shade? In the middle, between, right? This is the interval from -1 to 3. Is it open, closed, or half open? Half open. Yep. So this is a bounded interval that is half open. Any question on that?
So when you write that as the like parentheses stuff, you have to include the like bracket depending on the circle.
Can you be more specific than the word stuff?
Sorry.
As the so this is graph notation. This is inequality notation. Which notation are you talking about?
The one with the parentheses.
Any,
Bounded intervals.
An interval notation.
Yeah, interval notation.
Yep.
So the circles. I get it. Never mind.
So in interval notation, you'd be doing this.
Yeah, that's what I was. Because is the parentheses for an open circle?
Yes.
That's what that means. Okay.
Yep. So there's 3 different symbols that mean don't include. Parenthesis in interval notation, open circle when you graph, or just a less than without the equal to underneath it. Yeah. And then there's 3 symbols that mean to included. Put the equal to, fill in the circle, or use a bracket. But they're all used in different notations. But these all mean exactly the same thing. Okay, so when we are solving an inequality, it's exactly the same as when we solve an equation, except for one thing. If we multiply or divide by a certain kind of number, we have to remember to do something. Does anybody know if we multiply or divide by a what?
Negative.
A negative, what do we have to do? Yeah.
But you like flip the inequality sign.
Right, we flip the inequality sign. Yep. So if you only multiply or divide, not add, not subtract, nothing like that. If you multiply or divide by a negative, flip the inequality. Okay, so now we'll try solving a few inequalities. Okay, all of the properties that you know still work. You can add a number to both sides, subtract something, distributive, all that stuff is fine. This is the only thing we have to be careful with. Okay. So what would your first step be in that problem? Yep, we've got to distribute. So that's 3x minus 3 plus 2. What's minus 3 plus 2? Negative 1. So I distribute it and I combine like terms at the same time. Okay. What would be our next step? Oh, Nico, what would the next step be?
add 1 on each side.
Okay, we could add 1 on each side. That's going to take care of that. And what else could we do at the same time?
Subtract 5x from each side.
Okay, so we can minus the 5x. That takes care of that. Now I have negative 2x is less than or equal to 7. I didn't flip the sign because I didn't do any multiplying or dividing at all yet in this problem. But what's my last step? Yep.
Divide both sides by -2.
Divide by -2, and because we're dividing by a negative, what do we have to do?
Flip the sign.
Flip the sign. So now it's x is greater than or equal to -7/2. Any question on that one? So let's look at two ways we can solve inequalities on the calculator. We haven't had any inequalities yet that I don't think we can handle with the algebra. But eventually we might have some, and the calculator is a good way to do it. Okay, so the first method is to rearrange the inequality so you get 0 on one side, and then you're going to calculate a root. Or 0, same thing. So this method requires you to rearrange it and then calculate the root. Now, once you get 0 on one side, it's either going to be the original problem was less than 0, or the original problem was something like that, greater than 0. Okay, or you could have it equal to. But it's going to be one of those situations. So once you know where your root is, you have to look at what the original question was. Do they want to know where you're greater than 0? In which case, greater than 0 means they want to know positive. Or do they want to know where you're less than 0? Less than 0 would mean you're looking at negatives. Okay, so we just have to figure out where we're greater than 0 or less than 0. And again, which one? Well, it depends on what they give you in the question. So here's our question. 4x minus 1 is less than 2. What's the first thing I have to do with that if I follow method 1? Yep.
Get 0 on one side.
Get 0 on one side. Now, before I go any further, this probably isn't one that I would normally graph. Because, yeah.
Do you just change the number to 0 on one side? Or
No, I minus 2 from both sides
Okay.
to get that. Yeah. This isn't one that I would graph because if you were going to solve this by hand, it's really only 2 steps to solve it by hand. Add 1 on each side, and then divide by 4. That's the answer. X is less than 3/4 or 0.75. But we might have one that's not as easy, and that's where graphing it would come in handy. So let's finish graphing it and see if we get the same thing. X is less than 3/4. Okay, so we did step 1. We got 0 on one side. Now we have to graph it. So we're going to type in 4x minus 3. And we'll do zoom 6. So I graph it. And then what did I say you have to calculate? The root, or the 0, which is option 2. So pick our 2 points, do our guess, and here is what we get. So now we know where this graph is exactly equal to 0 at that number, 0.75. But the question is isn't where is it equal to 0? It's where is it below 0? In other words, that means where is it below the x-axis? That's what they want to know. Where is it down in this area, down here? Would I want to pick values to the right of this number or to the left of this number? Yeah? Left. If I pick values to the right, like if I pick 1, I'm up there. That's not less than 0. If I go to the left, like -1, and look at where that is on my line, that is definitely below 0. That's at like -6 or something. So they're interested in this part of the line, which means you need to pick values that go to the left. Anything less than 0.75. If this was a greater than symbol, then this would have been a greater than symbol in my problem. So that's all you have to do to solve it with a root. Get 0 on one side, and then it's either everything below this answer or everything above this answer. One of the two. I mean, I guess technically it could be equal. If they use an equal to symbol in their problem, then you should use an equal to symbol in your answer. So just copy whatever they do. If they don't use an equal to, then neither should you. Any question on the first method? Okay. So first method, you had to rearrange it to get 0 on one side, but you only had to type in one thing. Okay. The second method, you don't rearrange anything. You leave it exactly the way they give you the problem, but you have to type in two separate things. So this is the same question we just did one more time. So what we're doing is leaving the left side the way they gave it to me, and leave the right side the way they gave that to me. And you're going to put each of those in to the calculator. Now, just so we remember, I did 4x minus 1 in blue, and I did the 2 in red. That was red. That was blue. Okay, so let's graph them. And this time, we're going to calculate an intercept. We're going to calculate an intersect. And once we calculate that intersect, it's going to be just like we did the root. The answer is either everything below the intersection point or everything above the intersection point. It depends if the original problem had a less than or a greater than. We just have to look at it. Okay, so it's the same one we just did again. So let's calculate the intersect. Because they're lines and they only cross in one spot, and there's only 2 of them, pretty much just hit enter 3 times. Okay, so there's our intersection, 0.75. Now we want to know where, if you look at it in terms of the colors, where the blue graph is less than the red graph. Where is the blue graph underneath the red one? That's in this section, right there. If I want numbers in that section, should I pick values to the right of 0.75 or to the left? To the left, yeah. If you pick a value to the right of 0.75, pick like 2. If you pick 2, you'd be right there on the blue one, and you'd be right there on the red one. Is the blue one under the red one in that spot? No, we went the wrong way. If you pick a value like -1, you're there on the red one, and -1 is like down there on the blue one. Now you're underneath. So any x value that's smaller than 0.75 will work. You'll always be on this section, which is under the red line. So x is less than 0.75. So there's 2 different ways to solve inequalities. One method uses a 0. The other method uses an intersect. It doesn't matter which one you do. Okay. Any question on either method? Yes?
Is it always just gonna, like, the inequality symbol always just gonna be the same as the equation? We graph it?
Well, if you did this, and you wrote your problem like that, you've switched around what's on each side. That's the red one. That's the blue one. This time, they're asking you where the blue is above the red. So where is the blue greater than the red? So the answer to this problem would be when x is greater than 0.75.
Okay.
That's the answer to this problem. So not necessarily. Okay, so compound inequalities. We solved a single. Let's look at solving an inequality that's a compound or double. Okay, there's different ways to do it, but the method that I'm going to show you that works all of the time is to split into two inequalities. Split into two inequalities and solve. So this would be your first one. -8 is less than 2x. And this is your second one. 2x is less than 12. And remember, this always means and. So you'd have to write the word and. 2x is less than 12. Okay. When you solve each one, you just divide each side by 2. And for this one, we would get x is greater than -4. Now, I did rewrite that because when I do an inequality, I usually like the letter on the left. Letter on the left, number on the right. It's not wrong if you do this. I mean, technically, that is exactly the same thing as that. But I like that better. So we got that. And x is less than 6. You don't have to recombine that. You could, but it didn't say to. So if you leave your answer as x is greater than 4 and less than 6, that's an acceptable answer. Yes?
Could you just divide the whole thing by 2?
So if you're wondering, well, why don't you just do divide by 2, divide by 2, divide by 2? The problem with that approach is if I gave you something like this, since you have x's in all the spots, if you divided everything by 2 here, you still wouldn't have x by itself in the middle because you've got x's over here and over here. You're never going to be able to get x alone in the middle in this notation. It's impossible. You guys say, oh, well, I'll move the 5x to here. Well, if you minus the 5x from there, that's great. That's gone. But now you've got x's in the other spots. So now you have like a -3x and a -1x. And then if you say, oh, well, that's a -1x, I'll just add that x to get rid of it, but then you're going to put it back over here. So you're never going to be able to get x alone in the middle with this approach. But with this approach, you don't need to. So yes, there would be a slightly shorter way you could do this problem, but not that problem. Let's try this one. Okay, when I split that up, what would be the two inequalities it would split up into? What would be the first one? Yeah? And what would be the second one? Yep, Nico?
2x plus 5 divided by 3 is less than or equal to 5.
Yeah. And now we just solve each inequality. It's going to be the same 3 steps. Times 3, minus 5, and then divide by 2. So it's times by 3. And I'll do this one at the same time. Times by 3. Negative 3 times 3 is negative 9. And then those 3's cancel. 5 times 3 is 15. And those 3's cancel. And what's the next step? Yeah.
You would subtract the 5. and go back to 5.
So we do it there. That's gone. Do it there. That's gone. And now negative 9 minus 5 is negative 14. And then when you do it over here, 15 minus 5 gives you 10. It's always and. Just, I need to carry the word down. And my last step would be to divide by 2. So I get x is greater than negative 7. And again, I move the x to the left because again, that's where I like it. So x is greater than negative 7 and x is less than 5.
Wait. For that one, wouldn't it be negative 7 is greater than x? Because the sign, yeah. No.
Well,
No,
if
but the
I,
sign switched because you divided up top, right? Yeah, so the sign switches.
why does it switch?
Because you divide.
What did I divide by?
2.
I divided by 2. Is 2 positive or negative?
Oh, so it only switches if you divide by a negative?
Yeah, it only switches if you multiply or divide by a negative. Yep. So in that case, I did switch it at the end, but it's only because I didn't like where the letter was. I didn't switch it here because I divided by a negative. These are the same thing. I would prefer this one, but if you write that, it's okay. Yes?
Wouldn't it be x is less than or greater or equal to 5 instead of just...
Oh, did I forget to copy down? Yeah, equal to. Remember, always copy what they do. They have the equal to, so should you. If they don't have it, then you should. Yeah.
Thanks.
Any question on that? So that method of splitting it into 2 problems is exactly how we're going to solve absolute value inequalities. Okay, we did absolute value equations yesterday. This is the same thing. We have to split it into 2 problems. But the first thing we have to do is make sure the absolute value is isolated. So if I have this, is the absolute value isolated? I'm not going to solve this problem, but is it isolated right there? Luke?
Yeah.
Yep, that's fine. If it wasn't isolated, there would be something added or subtracted on the outside of the bars on the same side. And there isn't. It's just an absolute value on the left. So that's the first step. If it's not isolated, make sure you isolate it. And now the second step is to split it into 2 problems. Remember, the first problem, all you have to do is take away the bars. Just copy the original, get rid of the bars. When we do the second inequality, it's kind of like when you did the second equation yesterday. What was the extra step that you had to do when you did the second equation? Right, we took and we changed this number to its opposite. So that's what we're going to have to do when we do the second equation. Copy down the original without the bars, but we're also going to make the number on the other side the opposite. But with an inequality, if we make this number the opposite, we've got to do something else too. What else do we have to do? Yep.
Flip the inequality.
We have to flip the sign, yes. So the second inequality is just like the original without the bars, but you flip the sign and make the number on the other side of the equation the opposite. So that's the extra step right there. So when you're done, you're going to have two inequalities because you're splitting it into two problems. You're going to have one here, you're going to have one here. Whenever you write inequalities, you need a word between the two. What are the two words that we've been using?
Is it and or?
Right. It's either going to be and, the other option is or. It has to be one of those two. You can't just randomly pick whichever one you like. It has to be one or the other, and there's a way that you tell. The way that you tell which one it's going to be is you look at this symbol in the original problem. If the original symbol is a less than or a less than or equal to, then you have to put the word and. If the original problem had a greater or greater than or equal to, then you have to put the word or. And the way I remember it, how do you pronounce, what is this symbol again? Greater than? I call it greater than. Greater, right? If you pronounce it as greater, you'll remember it's an or. So a greater symbol uses or. And then the other one is and. So, greater. Let's look at this one. Very first thing, is the absolute value isolated? Yes, it is. Then it's already ready to split into two problems. We can figure out right now if it's an and or an or. We don't have to do any arithmetic for that. Is this an and or an or? Yep. This is an and because the original problem has a less than. So we definitely need an and. What's going to be the first inequality that I split it into? Yep.
X minus 3 is less than 3.
Right. That's the easy one. X minus 3 is less than 3. You just take the bars out. How about the second one? So we can take the bars out. We're going to do two other things.
Is it x plus 3 is, wait, no, x minus 3 is greater than negative 3?
So you take the bars out, flip the sign, and then make this number the opposite. So x minus 3 is greater than negative 3. Yep. And those are the two we have to solve. So the one on the left, we get x is less than 6. And x is greater than 0. So yeah, basically saying it's a number between 0 and 6. But it can't be 0 and it can't be 6. Could be 3.5, something in the middle. Yeah.
You said we don't have to like recombine it.
No, if they say to leave you can leave your answer in inequality notation, this is fine. If you wanted to combine it in inequality notation, that's how you do it. Now, if they did say to graph your answer and you write it like this, then this is wrong. If you're going to graph it, then you need open and closed circles. That's a different way to write the answer. Any question on that one? So let's look at the last one. So this one, it's a fraction, and it wants to know when this divided by that is greater than 0. Think about in general, when you divide two things, how do you divide two numbers and get an answer that's bigger than 0? What has to happen? Yeah?
The smaller number has to be able to like go into the bigger number.
So remainders or decimals are okay. That's okay. I'm thinking kind of more general. There'd be a rule for when you divide two things and get a positive answer. Yep.
2 positives or 2 negatives?
Right. If you're going to divide two things and get an answer greater than 0, you either have to divide two positives or you have to divide two negatives. Either case will give you an answer that's bigger than 0. One of these cases is impossible here. Which case would never happen in this one? Yeah? Yeah, you can't have a negative over a negative. I mean, yes, a negative divided by a negative is a positive, but why would that never come up in this problem? Yeah?
Because it's a positive
Because it's what?
a positive over a negative.
What do you mean?
Like in that equation, it's positive.
This is a positive over a negative?
Yeah.
This is a negative?
No, it's a positive.
This is always a positive. Right? You can't do anything to control that. This is going to come out positive no matter what you do. We can't plug in 2. Because if you plug in 2, that's another problem. Well, we'd be dividing by 0. So we're not even going to think about that. So you can plug in any number you want except 2. And then take the absolute value of it. The bottom is always positive. So if you can figure out what makes the top positive, then you'll get an answer that's greater than 0. Is the top always going to be positive? Like if I pick any number for x, is it guaranteed this comes out positive? No. I need to figure out when does it come out positive. And that's the answer to my question. So when is x plus 3 a positive number? If, yep,
X is greater than 0.
Like 3.
x is greater than what?
3. No, negative 3.
Negative 3. As long as you pick a number that's bigger than negative 3, the top will come out positive. The bottom is always positive. Who cares? It's an absolute value. Positive divided by a positive will always give you a result greater than 0. If you don't pick a number greater than 3, greater than negative 3, then the top will come out negative, and that won't work. Then you'll have a negative divided by a positive. That's not bigger than 0. Okay. Any question on that? Yes.
So would the answer just be x is greater than negative 3?
Yes. Well, I should add one thing. X can be bigger than negative 3, but it can't be what number? There is one number x is not allowed to be. X can't be 2. So technically I should add that in. So if you did it on a number line, it would look like this. It's anything above negative 3, but not 2. That's how it would look as a picture. Any question on that? So that's homework for tonight. It's a lot of single problems, so just make sure you double check if you copy that down. We'll go over that tomorrow, and then I think we'll also be finishing up chapter 5 tomorrow.